Hi, my name's William Malik. I'm Vice President for Infrastructure Strategies with Trend Micro. We're here to discuss bringing zero trust to industrial IoT. The reason that we're talking about this is that there are some pervasive security problems in the ICT environment, and zero trust is a fairly recent evolution of some information security concepts that is finding applicability across a wide range of environments in IT, and I believe can have a significant impact on improving the character of information security as experienced in the OT world. In the course of the talk, first I'll describe some of the problems that I see in industrial IoT security. We'll discuss what zero trust is and then bring them together. And I'll close with a couple of specific recommendations that should help you enhance the security of your environment. The first thing I'd like to note is that zero trust is not a thing. You can't buy it. It is an architectural concept. It's a way of organizing your information security componentry. And so a vendor tells you they're selling zero trust, probably doesn't understand what zero trust actually means. You can sell components that can support some of the elements of the zero trust architecture, and we'll talk about those components in a little more detail in a bit. But to begin, here's a little bit about me. I've been in IT for over 40 years. Began as an application developer, writing COBOL payroll applications at an insurance company in Boston. I went to IBM in Poughkeepsie, where I worked on the mainframe operating system. I was there for about 12 years. Then I went to Gartner. During the course of my Gartner career, I led the information security strategy service and also the application integration and middleware service. The turn of the century found me looking at an opportunity with KPMG to become a senior director for the national practice. Things changed after 9/11. I took a job as CTO of Waveset, an identity management startup, then worked for a number of years as an independent consultant, and then more recently worked for Cognizant as an enterprise architect. I was with Optiv as an identity management architect, and 4 years ago, I came to Trend Micro. My job here is to help make some of the complex ideas around information security clearer. That is not the same as making them simple, because this stuff ain't simple, but you can make it clear. And if somebody's talking to you and it doesn't seem clear, then they may not know what they're talking about, or they may not be trying to help you understand as well as they should. So if it's not clear, that's on me. My goal is to make it clear. So what are the range of concerns we have in industrial IoT security? Well, on the one hand, 5 months ago, we had a senior officer in the US Army remind folks working from home that their in-home IoT devices could pose a security risk. And he wasn't fooling. They're talking about Nests. They're talking about intelligent TVs. They're talking about Alexa and Siri. They're talking about smart cameras and doorbells. These things leak a tremendous amount of information. We've had problems where soldiers are jogging with their Fitbit and unwittingly leaving a trail that records the location of their base, sometimes in areas where there isn't supposed to be a military base. So that's one end of the spectrum. On the other end of the spectrum, also in May, we learned that Siemens PLC, this particular model, had a code defect that was given a severity score of 8.1. That's on a scale of 1 to 10, where 10 is really, really bad. 8.1 is above the oh snap threshold. You got to fix this one, because what it means is that code that's running in the PLC, in the user memory, which is supposed to be a sandbox area, can break out and take over system functions. It can interrupt or send IO. It can modify tables and so forth. So you got to get that one fixed. That's an important one. And the market's huge. The market's booming. Now, I've got here quotes from 3 different market research firms. Market research, the organization says, expect industrial IoT to get $1.1 trillion in 2028, which is a 70% compound growth rate starting from now. Meticulous research says it's going to hit $250 billion by 2027. starting last year with a CAGR of 16, slightly less optimistic. And then Grandview says that as soon as 2025, with a CAGR of nearly 30%, we're going to hit $900 billion. These are vast amounts. The point here is not to throw rocks at folks making predictions. The important point is to be generally right, not precisely wrong. The 4 digits or 5 digits of precision may be a little over the top, but the overall trend and direction is substantial. And what you'll see here is in all of these cases, we're looking at growth rates that are leading to doubling or tripling in size over a small number of years. So the market is booming. A lot of stuff out there. Technology is getting cheaper. We're getting smarter at how to make even antennas less volume intensive. We're looking at ways to make complex componentry cheaper, less costly, and still equally efficient. And this is leading us to a real problem because the market's growing. The technology that support the markets is getting cheaper, which means we're putting a blue million more of these pieces out there than anybody suspected, even just 5 years ago. But we're not doing that well, making sure that it's secure. According to a study that we did at Trend in 2020, over a couple months period surveys, we found that only a little over a third of organizations actually got their security teams involved when looking at industrial IoT technology cases. I should point out these are corporate organizations doing large-scale industrial projects. We're not looking at home here. Secondly, over the course of the period, most organizations encountered 3 attacks on their device. This was a 2-month-long survey window. So that's a fairly high density of attacks. In another talk, I've actually gone through some research that Trend did on attacks. We set up a honeypot. It fooled Shodan. We were out there for 2 months, and we got an attack just about every week over the course of those 2 months. Some of them took down our system. We actually had some white hat hackers telling us, "Hey, dude, your system's not secure." And it's like, oh gosh, yes, thank you. Anyway, and we noticed that over 9 out of 10 saw instances where what they were doing with our IoT implementation was leading to threats against what they saw as critical infrastructure. So what do we do about this? Well, let's secure it. That's not easy. Why is it not easy? Well, it's not easy because we've got a set of challenges solving these environments. The infrastructure is complex. We in the IT side have kind of been basking in the glow of the simplicity of things like our networks. Back in the 1990s, we had Novell NetWare, we had Banyan Vines, Microsoft was just coming onto the scene. The internet was not yet that big a thing, and IBM had SNA. These protocols were all competing as ways to handle large networks, and we kind of settled on IP for most cases. This didn't happen in the industrial IoT area. There are many, many protocols, many, many ways to connect devices one to the other. And protocol converters are actually a fairly healthy market segment and growing just to allow these devices to talk to one another. That complexity, in other words, is being band-aided. It is not being resolved. We're also making things harder because we're mixing our IT and OT systems. Somebody in the senior leadership team read a magazine on a trip, and it said, you can improve your business's efficiency by having data everywhere. So now we want to make sure that our daily production statistics in the factory are being fed directly to a server, which can then broadcast information to the folks in accounting so they know how many tires and wheels we actually shipped that day. The problem is that when we mix these networks, we didn't throw any boundaries in them. So we have these large flat networks across which anything can go just about anywhere. And that's a risk. We have inadequate controls. Part of this is technology limitation. You don't have the bandwidth or processing power or memory space to run complex security analytics on the devices that are actually doing the work. Now, some vendors, ARM and others, have put out chips that have significant coprocessors, and those coprocessors are designed to be able to handle things like generating a digital signature, encrypting a message, signing a document digitally, doing advanced logging, doing some kind of analytics on what the processor is looking at, tracking the inflow and outgoing data from the device. But the fact that it's in the chip doesn't mean that the vendors using the chip to build the technology you're buying are actually enabling that capability. So we're partway down the supply chain. So the security controls are tough to deploy. People are worried about putting stuff in band in the networks because it'll slow down throughput. You don't want to have a device stop because some sort of security activity is taking place on it. And we've got obsolete design principles. And I'm throwing the rock at me. This is talking about information security design principles that just don't scan in the OT world. See, in IT, there are three basic principles. One is data shall not be lost. Another is data shall not be altered. And the third is data shall not be inadvertently disclosed. Those three principles are usually rolled up into the acronym CIA for confidentiality, availability, and integrity. But notice we're talking about the data, not about the underlying process. So if there is a problem, turning off the device, modifying it and restarting it is an entirely appropriate answer. That doesn't work for devices that are running continuous processes. You can't turn off the furnaces in order to get a security patch into the blast furnace arena. Doesn't work. I grew up in a copper mining town in southern Arizona, and the smelters could not be turned off. If you shut down the smelters, the slag would solidify, and the only way to fix it was to dynamite the refinery and start over. So yeah, you can't turn off some of these processes. On the contrary, in the OT world, the overarching design principles are safety and availability of the fundamental service. And the example I like to use when talking with my IT buddies is that means that when an escalator stops working, it doesn't just tumble everybody aboard all over the place. It doesn't go slack and roll down to the bottom. When an escalator breaks, it comes to a stop and it locks in place. And guess what? Even if it's not working, you can still use it as a stairway. That's a really, really intelligent design. And so this conflict of design principles, what is not acceptable from an IT perspective, may sometimes lead your IT colleagues to say things that you would look at as perhaps unwise. Just smile and nod and say, okay, now consider these additional constraints. Now how would you change your answer in light of these new facts? So there are challenges securing the industrial IoT environment. And in the IoT environment, we see a set of problems that have been growing. In 2018, we identified through our sensors 466 separate ICS vulnerabilities. We're affiliated with an organization called ZDI, the Zero Day Initiative. They actually pay money to people who find security defects, and then they go through a process of responsible disclosure, working with the vendor to get those defects fixed. Over half the defects that are reported in Microsoft come through ZDI. So they're looking at ICS now. They've got nearly 900 in 2020. I don't know what the count is for calendar year 2021, but with the shift in work patterns, you can believe that the stress on IoT and industrial IoT is much greater. In the occupational technology domain, we find that much of the technology is not managed by IT, which, given the architectural mandates, probably is not a bad thing, but having the security team around certainly could help. It's rare. And finally, HMI devices are not really designed for the kinds of connectivity that we're beginning to see in these environments. They're hard to patch. You can't bring them down. Do you run duplicate in a hot standby mode so you can bring one down, move it from the N level to the N+1 level, resync, and then take the other one the same step forward with failback? It's a non-trivial problem, but sometimes that's what we have to do. When we look in more detail into the industrial environment, we see a number of weak points. We're looking at malware attacking databases. We're looking at vulnerabilities in gateways, hacking of devices. Industrial robots are actually an interesting problem. Trend did a report about that maybe 9 months ago. The issue is that the programming language used for industrial robots are fairly simple. They're fairly straightforward. You can move things. You can get data. You can also read from any legitimate input. You can write to any legitimate output, including stuff that is network connected. There are no inherent capabilities for security in any of the programming language we looked at. And these programming languages have fairly small install bases. I mean, as compared with things like Python or C. A manufacturer, ABB, may have 10,000, tens of thousands of a particular type of robot out there that uses a particular programming language. Well, if your top line market is 10,000 installs, then as a vendor of the code that can scan a program for defects, you're probably not going to put that on the top of your list when you've got 100 billion Android devices out there that you can go get a few bucks from. So the result is there are no third-party products that will do either static code analysis or runtime analytics on the industrial programs for running robots. And they're very powerful, which means that it's possible to sneak in a bug. Well, how would that happen? Well, if you've done work with industrial robots and programmed them, you know that it's a small community of users. It's a subset of the users of that device. And when you come up with a solution to a problem, you're likely to share it because good people like to share stuff. And so you'll take your program and you put it into some sort of a shared file or library or repository where other users of that technology can now download it and go forward. The problem is that the controls over those shared locations are not that strong, and it would be possible for somebody to slip in some code. Most of us don't read the stuff that we download. We don't decompile working object decks. And so there could be malware lurking inside of the stuff that's in there. And this is part of your software supply chain that then comes to life at some later time, as when you've now turned on your 500th device. So there is a load of vulnerabilities in the industrial environment, from supply chain to the absence of alerting, the flat networks, no impediments. So why are we talking about zero trust? Zero trust can operationalize 62443. What I mean by that is the standard, which the developers are actually looking at, ISO 27001, they're looking at COBIT, they're looking at other models, they're looking at NIST Special Publication 800-53 for ideas about how to secure technology in a way that is consistent with the overarching design principles of OT. And so zero trust is a way to go in and say, okay, let's see if there is a architecturally comprehensive way to eliminate these classes of vulnerabilities. So instead of patching this one problem and then patching the next one, I can do something to prevent that whole class of problems from ever appearing in my environment again. That's the smart way to solve the thing. So let's categorize the vulnerabilities that we've seen, looking at the past couple charts, in IoT. There are problems of device identity. Am I talking to the device? I think so. Are there as many PLCs in this subnet as I expected, or is there an extra one doing weird things? How do I know that my commands are being executed on the proper thing? How does the device know that I am who I say I am? So the broader question of identity management comes into play here, and the identity of the devices. Are they manageable? Are they recognizable? Can I correlate what logging I do have with the actual device that generated the log? MAC addresses can be forged. Unfortunately, it's not a surefire way of identifying. Yes, it's another tag, but it's not bulletproof. Network traffic is an area of vulnerability. Because of the constraints on available bandwidth and because of concerns about throughput and performance, most organizations are reluctant to put inline performance monitoring and analytical tools into the data streams, and rightly so. Fortunately, we do have devices that can take a feed out of band and route it for additional analysis. These things are not cheap, and you're not going to put a bunch of them out there. But if you segment your network, it might be nice to have something like this capability at the network edge so you know what's coming in and what's going out. You can use information diodes. If a certain device is generating reports, it doesn't really need to receive traffic generally, so you can just shut down inbound traffic entirely. Instabilities in the endpoints. Here, what we're talking about are things that would cause you to cease to trust a device. That you'd say, this thing's odd. Like, we just got an urgent message from the CFO that we need to send $5 million to this vendor to close this deal by the end of the quarter. And oh my gosh, it's Thursday and the quarter ends tomorrow. But when was the last time the CFO sent us a message from Lvov? I didn't know he was going to be in Eastern Europe. Maybe we should make a call, right? Is that endpoint trustworthy and reliable? And we'll talk about network access control in a few moments. The integrity of the server is another issue. With flat networks and with the number of entry points, it is possible that the processes on a server can be corrupted. They could run installs. I mean, why in the world would you need to run a compiler on an industrial robot? Well, the answer is you don't, but we don't have controls in there. And I talked already about the software supply chain, including cloud-based attacks and the existence of shadow cloud. What's that? That's when you put in a piece of software and it brings along a little piece of cloud with it. A simple example, you start up iTunes and you have an iCloud repository. You still have to figure out how to log into it, but there are an awful lot of software as a service capabilities that drag along a hunk of cloud as part of their installation protocol, and that can be a problem. So what do we do about these vulnerabilities? Well, zero trust helps, many of them. And I'll tell you a little bit about what it is and then what we do with it. Zero trust comes from the idea that you do not assume that someone, by virtue of the fact that they're on the network, is able to do anything they want to do. It's obviously not zero trust because there has to be on the network a trusted source, and you have to be able to, allow that unauthenticated, as yet unidentified entity to submit credentials, and if they pass a certain number of tests, they'll do it. So network access control, which was introduced in the late 90s, brought along the idea that you have to prove you are who you say you are, and your device has to live up to a set of standards before it can be connected to the network. Georgia Tech has an open network. Anybody can get their Wi-Fi and you can see it. Now you can try to log on. You have to have a user ID and password to log on. But once you've done that, before you can connect to specific capabilities, the network, the system is going to scan your device and see, are you running current anti-malware? Have you done a scan recently? Is your operating system relatively current? Are there critical updates that are missing? Has this device been doing weird things like generating tons of traffic or burning up cycles on obscure processes, maybe doing crypto mining? If any of those tests fail, then your device won't get through, even if you do have credentials. Instead, it'll be routed into an anti-room where you can clean up your act. And once you've downloaded the updates, once you've run the scans, once you've decluttered the machine, then you can come back and maybe we'll let you in. That's network access control. Unfortunately, NAC did not last a terrifically long time, but in parallel with it, there was a group that became known as the Jericho Forum. And these are information security professionals who said, we want to make sure that people don't rely on a perimeter to solve their problem. It's nice to have a boundary, but just because somebody's on the inside doesn't mean they're trustworthy. The Jericho Forum, named after, of course, Joshua at the Battle of Jericho, where the walls came tumbling. That's what the picture refers to. That is Joshua leading the troops. The Jericho Forum worked hard to get the idea that whenever you're relying on a perimeter, you're making a strategic error. And they were around until about 2009. They turned over their work products to the Cloud Security Alliance, which remains today. The Cloud Security Alliance generalized Jericho Forum and included capabilities for dealing with multi-cloud environments. Useful group to be part of. And then finally, again, out of the late 90s and early 2000s, the concept of user behavior analytics came in. And that's where you dig deep into the device and say, not only is the person who he says he is, but he's where we think he should be. He's doing something that's relatively conventional compared to past use. And there isn't any indication that the device was misbehaving recently. Now, if you put all those things together, you have the foundations of zero trust. Predicates for zero trust are identity management. We got to know who you are. We've got to have an IDM solution in place so that we can then authenticate you. And we've got to do some basic hygiene on the network. We've got to provide some segmentation. Those are prereqs for zero trust. But with those prereqs in place, you now can follow the guidelines of zero trust architecture. NIST special publication 800-207 looks at defines zero trust. It talks about how it should be used in federal government programs. And there's a link there to reference it. You can just Google special publication 800-207, get a current version of it. Very, very useful piece of work. It will help you avoid problems. The fact that it has reached the status of a special publication means that it can be taken seriously across the IT community. Zero trust will allow you to keep bad things from happening because you're going to follow one of these or more of these technologies to get there. First, we're going to verify identities, which means we have an identity management infrastructure. We're going to ask for multi-factor authentication. By default, we want people to not rely on static passwords. Just putting in multi-factor authentication itself will basically block any kind of password spraying attack. Now, there was recently a kerfuffle where one vendor was saying that their form of multi-factor authentication was superior to an SMS message. And well, yeah, but the fact is that even an SMS message to your phone is a heck of a lot better than a static password. And the old notion of changing your password every 3 months, that's nonsense. When the bad guys get a password, they're hammering on that thing within 48 hours. Delaying the change for 3 months means effectively you're never going to get to that change. And also, I should point out, NIST has upgraded their password guidelines. We're no longer looking for, complex character sets, upper, lowercase, along with numbers and symbols. We just want length. Wave, cloud, dog, barking. All lowercase, no special characters. That'll take you hundreds of billions of years to crack. Why? Because it's long. Replace the O with a 0, and yeah, now you're up to, double the number of billions of years it'll take. But that's not the important point, and the first one is going to be relatively easy to remember. So go with longer passwords if you must, but don't rely on changing, and certainly don't rely on intricate, character sets to solve the problem. Use multi-factor authentication. We want to restrict network access. We want to put DMZs in place. We want to carve up the network. Back in 2017, Taiwan Semiconductor Manufacturing Corporation had an incident where a technician brought their laptop onto the factory floor and plugged it into an industrial robot to gather some statistics and unwittingly uploaded a virus. How did a virus get into an industrial robot? Well, it was running Windows 7. Why in the heck would you run Windows 7 in an industrial robot? Well, because the manufacturer built it with Windows 7 in there, and if you meddle with the software, you void your warranty. There is no mechanism for upgrading the software in most industrial robots. And so you've got vanilla Windows 7 running all of these things. And guess what? The virus got in there, it found no impediment, and it spread across the factory floor. It hit 100,000 devices in 40 seconds. You could see it, but you couldn't stop it. It was a wildfire. Now, if they had segmented this factory into 100 zones, it would have taken 1,000 devices down, but 99% of the capacity would have been preserved. As it was, the entire configuration was down for more than a week, and it actually impacted Taiwan's GDP. So segment your network. I'm thinking about things like these massive solar farms they're putting up in the Middle East, where you have 5 million panels, each of which has got 16 inverters and a PLC. You want to make sure that there are fire breaks. You want to make sure there's a way to make it hard for the bad guy to get where they want to go, as well as to stop the spread of malware, to stop lateral movement, which is one of the techniques that the bad guys use. We want to default deny. We want to safe list applications. We do not want to run installs on machines in the production environment. We do not want to run compilation of technology in the industrial environment. We do not want to use weird protocols. We do not want to run unconventional programs. If the machine's been in production for a certain number of time, we know exactly what programs it's going to use, and anything else should be blocked. You can do that. And finally, we want to monitor what's going on with the devices and with the identity of our users periodically. Maybe not continuously, but let's say every 15 minutes or every couple hours, we want to see, is this device continuing to behave properly? And if you do those four things, and it doesn't matter which order you do them in, they are independent in that regard, you will be moving towards the group on the right, which is the zero trust environment, which is called Secure Access Service Edge. Now, Secure Access Service Edge is, in fact, the name for different products from different companies. What it stands for is I have a cloud access security broker, CASB, that's going to determine who has access to apps and which apps I am allowed to see. I have a secure web gateway, which is going to block requests for unfamiliar things. That's how you shut down shadow cloud, right? And then the second half is I'm going to go beyond a traditional VPN. I'm going to use point-to-point specific security. I'm going to use zero trust network access, which means when I want to connect to a particular service, I authenticate myself to that service and I have permission to use that for a defined period of time. Once that period of time is over, the session drops. Nobody else can come into it, and having that access, I do not have automatic rights to anything else. I have a VPN to get into the systems at Trend. I don't use it. The VPN goes to a hub, and from that hub, I would have access to a lot of directories. I don't want that. I have a direct secure connection to my email system. I have a direct secure connection to my groupware. I have a direct secure connection to those repositories that I need to access for generating and filing and distributing reports. I don't need other stuff. I have no need to look at corporate financials. I have no need to look at what's going on in the development environment. And so I do not need those kinds of capabilities. So my user profile says what services I'm allowed to access. And they also have behavior analytics so that they know where and when I'm supposed to be. So if I finish this recording, I finish this talk and I go do something else, someone says, wait a second, Bill's on the East Coast. He's not supposed to be in, South India. So what's going on? So SASE and ZTE become a platform from which I can now begin to lock down what's going on in the OT community. Why is it so hard to secure industrial control systems? It's harder than it is for IT for these reasons. First, some of these systems are not patchable. You can't upgrade the software on an industrial robot without voiding the warranty. It's even worse in healthcare. The systems that are used in hospitals for patient care have to go through FDA certification. The FDA certification includes not just the technology, but it includes the software version that technology is running. And the certification process can take from 5 to 7 years. So when you go into a hospital, the equipment monitoring you and the hospital bed itself are running software that has not been updated since at least 2016 and possibly much earlier. That's a problem. The FDA recognizes this and they're trying to come up with a way to accelerate certification and authentication for software upgrades going back perhaps 2 years, but that's still an awfully large window. Most industrial security vulnerabilities back in 2018, when he started looking at them, were live for more than 200 days. Now, for most vendors, it's down to under 60 days. Hooray to you. That is a hard thing to do, and your vendors are doing it. So patches are hard, but we're making headway there. The absence of malware protection is a huge problem. We talked about the fact this technology doesn't have spare cycles, doesn't have spare memory, doesn't have bandwidth. I mean, the most heroic piece of industrial IoT that I can think of is the Voyager spacecraft. It has 3 processors. It's got an aggregate processing power of 200,000 instructions per second. They've got about 1/4 of a meg of memory. They've got about 240 watts left in their, they use plutonium to drive a heat exchanger, which generates electricity. It's half exhausted. Okay, so that thing's a long way from home, and they don't have room to run a malware scan, and they certainly aren't going to spend bandwidth downloading updates because it takes 19 hours just to get a signal to them where they are now. Another problem with ICS security is we have still the notion of a perimeter. And once you're inside, it's easy to go across the whole configuration pretty rapidly. That's a vulnerability that we can address with network segmentation. Harsh, difficult environment. People don't go there. Nobody's made a field trip to Voyager. Nobody's been able to get a replacement battery to the older rovers up on Mars. It is a tough place to go. In the middle of winter, you're not going to want to climb a utility pole or, hang around inside of a self-running hydroelectric power plant in order to run a patch on a system. We recognize that. We have profound problems with conflicting architectural mandates. That's on us. We don't understand in the IT side the fundamental importance of safety protocols that are inherent in the way you design things in OT. And the worldwide deployment is a big problem. So how do we fix it? Well, here are 3 groups of answers. Right now, I would like you to begin segmenting your network. Not every piece. You don't want to end up, going from 10,000 devices in one flat network to 10,000 network segments, because now you've got a different problem. Now you've got to figure out how to manage 10,000 policies. But, figure out where the balance is. Do I want to split it in half? Do I want groups of 100? Do I want it to be cells involved with production? What's the graininess? What's the granularity with which you want to segment your network, bearing in mind that there will be a cost associated with managing those protocols and dealing with, whatever alerts they throw. I'd like you to deploy zero trust architecture in any one of its forms. I'd like you to work on the identity management component. I'd like you to work on multi-factor authentication. I'd like you to work on user behavior analytics. And by the way, the good thing here from a project planning perspective is these things have independent value regardless of whether or not the whole project comes to completion on December 1, okay? You can make forward progress on these initiatives asynchronously. You don't have to go through 3 years of budget cycles to see any results. You deploy multi-factor authentication and you are immediately protected from password spraying attacks, right then and there. You upgrade your identity management infrastructure and you are immediately protected from obsolete IDs or the IDs of disgruntled employees of being accessible anymore. They're gone. So you get significant improvements in your capabilities right off the bat by deploying those pieces. I want you on the second side to take a look at monitoring your safety systems using out of band, using ways to look at network traffic without interrupting it. I want you to take a look at your supply chain. Where did stuff come from? This is going to lead you to build some kind of software asset management database. Yeah, start with Excel. You'll get to something better someday, but start. Take a look at what stuff you have in production. Where did it come from? When was it last upgraded? Who last used it? Do we still need that componentry? Does the vendor have de facto access into the system where this stuff is running? Where possible, upgrade your OT capabilities to take advantage of the smarter chips and the associated improvements in security capabilities. And for those of you running environments where you're considering 5G non-public networks, go forward with that. 5G non-public networks are a vast improvement from a security perspective over Wi-Fi. The problem with Wi-Fi is if I get nearby, I can pick up that signal, and then I can begin figuring out how to get in. If you've got a non-public network, there is no way I am going to even be able to connect. So that's a good thing. That's one of the things about 5G that really matters. Now, the full 5G isn't going to be available for a few years. 3GPP is working on REL 18. It's just starting. It's not going to be done for 2 full years. We don't expect REL 18 to be completed until we get into the spring of 2024. At that time, they'll start building devices that are compliant with a full 5G. But on the way there, you can make improvements. And finally, when it comes to your development processes, when it comes to your organizational structure, use security generalists where you can. Find smart ones, and you're able to define what that criteria is, people you can work with, people who understand. Use secure coding practices, and I'm thinking particularly about the coding languages for industrial robots, and explore using a managed security operations center. Let some people who know how to handle these alerts, insert them into the loop so they can take that traffic and dissect it and analyze it and give you a result rather than news that you've got 50,000 alerts today. And yesterday it was 48,000. So we've seen a growth of 4%. We don't want to just deal with that kind of stuff. That's not enough. You need something a little more granular, a little more informative. The material that make up this presentation comes from the following sources. I'd be happy to distribute a copy of this to whomever asks. You can get it through the organizers as well. Thank you for your time and attention. I'm William Malik TM on Twitter. Have a good day.